In this video, I'll be going over the 4 units we covered this semester in science, as well as going into further detail about one specific lesson from the unit. For the chemistry unit, I will be talking about acids and bases, more specifically the differences and similarities between the two, as well as how red and blue litmus paper react when coming in contact with both of them. Acids and bases have a specific set of characteristics that help make them identifiable. Before using a specific tester to figure out whether you have a base or an acid, there are specific sets of characteristics that can help you identify whether you're dealing with an acid or a base. For acids, the characteristics are as follows. Does it taste sour? Does it dissolve in water? Is it more corrosive to metals than living tissue? And is it a good conductor of electricity? Some examples of everyday acids that you might be able to find in your house are citrus fruits, vinegar, pickles, and even yogurt. Just like acids, bases also have a specific set of characteristics you can use to identify them. These are the characteristics. Does it taste bitter? Does it feel slippery? Is it more corrosive to living tissue than metal? And does it conduct electricity, but not quite as much as an acid? Some examples of everyday bases include eggplant, hand soap, and dark chocolate. In order to figure out if something is an acid or a base, we have to use a pH scale. pH stands for power of hydrogen, and it can be measured on a level from 0 to 14. This is a pH scale. Everyday items such as lemon juice and hand soap all fall into their place on the pH scale. The closer to 14 the item falls, the stronger the base is. The closer the item is to 0, the stronger the acid is. The pH scale is logarithmic, meaning that each time the pH goes up by 1, the solution becomes 10 times more acidic. Here are some examples of this statement. This also shows where each item will fall on the previously shown pH scale. Here I've drawn out an example to show the logarithmic side of the pH scale. I decided to use lemon juice and hand soap, which I used as a previous example to show you this. Lemon juice has a pH of 3 and hand soap has a pH of 9. So we subtract 9 from 3 to get 6, which means that our answer will have 6 zeros, meaning that lemon juice is 1,000,000 times more acidic than hand soap. Here I have drawn a pH scale, which goes from 0 to 14, having 7 marked in the middle. Here we have hand soap, which I used as an example. It has a pH of 9, which means it is a base. Here we have lemon juice with a pH of 3, which means it's an acid. Here in the middle is 7, with water. There are many different ways to figure out whether something is an acid or a base. Some common ones used by chemists are red and blue litmus paper. One thing chemists use to figure out if something is an acid or a base are red and blue litmus paper. Litmus paper is paper stained with litmus, which can be used to indicate the acidity or alkalinity of a substance. Blue litmus paper turns red when touched to an acid and stays blue when in contact with a base. Red litmus paper stays red when dipped into an acid and turns blue when it is inside of a base. Here is a short video of somebody using red and blue litmus paper to decide whether things inside of their house is an acid or a base. Here we can see as he dips the blue litmus paper into the lemon juice, it turns red, signifying that the lemon juice is highly acidic. Next he goes in with red litmus paper and it stays red, which indicates that it is again acidic. As he dips the blue litmus paper into the water, we see no change, meaning that it is not acidic. As he dips the red paper inside, we also see no change, which means that it is neutral. As he dips the blue litmus paper into the milk, we can see a little bit of change, which means that this milk is slightly acidic. Next he goes in with red litmus paper, and again we see a little slight bit of change, which means it is a small amount of base. As he dips the blue litmus paper into the coffee, we see a drastic change in color, meaning that that coffee is highly acidic. And as he dips in the red litmus paper, we see no change, meaning that it is still acidic. For the physics unit, I will be talking about concave and convex mirrors. More specifically, what it looks like when light reflects off of each of them, and what an image looks like when it's reflected off of each of them. The blue line you see in this diagram is a concave mirror. That's a mirror that curves at the center, like the inside surface of a basketball, and it is used to focus light or images. Some important things to note in this diagram are the letter C. That is our center of curvature, which means if the reflective surface was a full circle, that would be the center. We also have our principal axis, which is a straight line right through the center until it meets the mirror. F is our focal point, and that's where all reflecting light meets. And our focal length is from the reflective surface to the focal point. As we can see, when the light hits the concave mirror, it all meets at one point, and that is the focal point. Next, we're going to look at what it looks like when an image is reflected off of a concave mirror and all of the characteristics that it has. The three main categories for characteristics when looking at a reflected image are location, orientation, and size. As we can see, the reflected image is upside down, closer, and also smaller than the original image. Next, we're going to look at convex mirrors and what light looks like when it hits a convex mirror, as well as what a reflected image looks like. This is what it looks like when light hits a convex mirror. A convex mirror is a curved mirror that bulges out, like the outer surface of a basketball. It offers a wider or panoramic view of an image. As we can see, the focal point and the center of curvature are both in different spots on the convex mirror diagram. Both are inside the mirror, and the light rays act like they pass through the focal point, but they really don't. Since the focal point is inside the mirror, rays spread out as they reflect. As we can see, as the light reflects off of the convex mirror, it acts as if it passes through the focal point and deflects in all different directions. Next, we're going to look at what it looks like when an image reflects off of a convex mirror. As we can see, when an image is reflected off a convex mirror, it is always further away, upright, and smaller. Next, we're moving on to biology, and today I'm going to be talking about the circulatory system and how it responds to exercise. The organs that make up the circulatory system are the heart and blood vessels, including arteries, veins, and capillaries. The heart has the important job of pumping oxygen-rich blood from the lungs into the body and pumping carbon-rich blood from the body into our lungs. The heart is composed of 4 chambers, which are shown in the diagram: the right atrium, which receives carbon dioxide-rich blood from the body cells, the right ventricle, which pumps carbon dioxide-rich blood into the lungs, the left atrium, which receives oxygen-rich blood from the lungs, and the left ventricle, which pumps oxygen-rich blood into the body cells. The circulatory system also includes blood vessels such as arteries, veins, and capillaries. Blood vessels transport blood to all different parts of the body. Arteries are blood vessels that carry blood away from the heart and towards the other parts of the body. Arteries get narrowed the farther they get from the heart. Veins are blood vessels that carry blood to the heart. They have valves that keep blood from backing up as it is carried towards the heart. Capillaries are the smallest blood vessel and is where the gas exchange takes place. Oxygen, carbon dioxide, nutrients, and waste diffuse easily through the capillary walls. Now we're going to look at how the circulatory system reacts to exercise. Every time the heart beats, blood is ejected from the left ventricle and out into the arteries. Each heartbeat pushes blood throughout the body, carrying oxygen-rich blood to the tissues. As people exercise, their heart will become stronger and will be able to pump more oxygen-rich blood around their body. Exercise improves the circulatory system by making it more efficient. When you work out, your muscles use energy. They consume oxygen and produce carbon dioxide, which your circulatory system carries in and out of the muscle. For our last unit, which was climate change, I'm going to be talking about the greenhouse effect. First, we're going to be talking about global warming and climate change and the difference between the two. Global warming is an increasing trend in average temperature around the world. It may be colder some days, but on average it is warmer. So what's the difference between global warming and climate change? Global warming only includes temperature, whereas climate change deals with rain patterns, floods in some areas, droughts in some other areas, and storms. So what is the greenhouse effect? Well, it's a natural and necessary process to trap heat inside of our atmosphere. Without it, the world would experience extreme weather changes. Now I'm going to show a diagram that is very similar to the one we worked on this year. I'm going to explain what each of the 5 rays does when it hits the atmosphere. So before we get into what each of the rays does, I'm going to explain what we see on this diagram. The yellow circle in the top corner is our sun. All of the orange and red lines are sun rays that hit our atmosphere. The light blue circle around the Earth is the atmosphere, and obviously the planet in the middle is our Earth. So, working from left to right, we're going to go through each ray and explain what it does. Ray number 1 bounces back off into space. Ray number 2 is absorbed by plants and other green things on our planet. Ray number 3 is absorbed by structures and roads, but then released as heat. Ray number 4 reflects off into space, but it thickens. Ray 5 reflects back because of the greenhouse gases, and this is what we explain as thickening of the atmosphere. Are our main greenhouse gases. First is carbon dioxide, commonly known as CO2. It is the most significant because our activities affect it. Things like driving a car or factory production all produce CO2, which goes into the atmosphere. Its combustion reaction is fuel plus O2 equals CO2 plus H2O. 250 ppm is equilibrium. 300 is the highest historical value, but the current ppm is 420.23 ppm. Number 2 is water vapor. It creates 70% of the greenhouse gas effect. The concentration of it is constant, which means it is the same all the time. And third is methane and nitrogen oxides, but the concentration of those two are lower, so it's really not as important as carbon dioxide and water vapor. Finally, we're going to talk about ppm and ppd, which I just mentioned on this previous slide. ppm stands for parts per million and ppd stands for parts per billion. And basically what that's talking about is parts of gas. So that pretty much wraps up my favorite lesson from each of our 4 units this semester. Thank you for a great semester, and I hope you have a great summer.